Hello, everyone. Welcome to Always Coding, our weekly Hacky Hour. My name is Komal Devjani. I'm a developer advocate with alwaysAI, and I'm joined today by Laila Milani, who is a developer advocate and software engineer at alwaysAI, and Steve Grisette, who is the CTO at alwaysAI. So welcome, both of you, and thank you for joining. We're hosting another round of open office hours, and we want to hold this space for you to ask any questions you might have about alwaysAI, computer vision, or share what you're working on. At any time, if you're interested in going through some of your projects or debugging something, just let me know and I can give you access to share your screen. Speaking of which, I'm going to give all the panelists access to share their screen. And today we're going to cover starter apps. So this is a new year. We want to get started fresh and make sure that everyone can follow along. And we're going to be covering the basics of getting started with alwaysAI. So with that said, I'm going to share my screen and just get started with a simple object detector. So we're going to navigate onto alwaysai.co. And as always, you want to make sure you've registered for an account at alwaysAI and then navigate into your dashboard. The dashboard is really amazing to check out some of our popular starter apps. You can try out the Hello World face detector and learn more about how to train a model using the model training toolkit. Additional resources below give you the ability to set up your edge device. That could be a Raspberry Pi, NVIDIA Jetson Nano, or another edge device, so you can follow the instructions here. And the most critical thing you'll do is install the CLI. So click Install CLI, select your operating system, hit Next, and this big red button will navigate you into downloading the CLI. Once you've downloaded it, make sure you start the alwaysAI app and follow the instructions to make sure it's been added to your machine. So we're going to do something really simple today. We're going to go into our projects. And as you can see, I've already created a project for office hours. So let's go ahead and click into office hours and take a look at the model we've added. So I've added this Cocoa model. To learn more about the Cocoa model, you can just click the model and it'll navigate you here onto the model catalog, which gives information about what this model is and the performance numbers on various edge devices, as well as all the labels. So to run this project, what I want to do is just simply follow the commands right here on the dashboard. So you want to copy this and then open up an empty terminal, open up a directory. Hopefully this is big enough for everyone to see. I'm just going to hit paste and enter. And I'm going to proceed with the download and save it to my local computer. And just double check when you've added a new model onto your project, you want to open up your app.py file and make sure that the given model is instantiated here on the name. So here, as you can see, this is identifying the MobileNet SSD model, and we want to use the Cocoa model. So to change that, you want to navigate back into your dashboard, click into the model, which will take you here, and copy this over here, the name of the model, and paste it in your app.py file between the quotes, and then just hit save. So that should be good to go. And then what we want to do next is AAI app install, and then AAI app start. So in a couple moments, this should start working, and it'll give us what model is being added, what app I'm running, and you just want to copy this streamer link and then paste it into an empty web browser. So as you can see, it can identify me, a person, my couch, and I don't know if you can see, but our dog Charlie is there, but it can't identify that because he's napping. And if you want to learn how to customize the streamer or build an interactive web app, you can join us next week where we'll cover the details of how to do exactly that. So I'm going to stop right here and see what types of questions we're getting. And the first question is, does model training now support MobileNet v2? And Steve, if you're on, you can feel free to take on this question.
So I'll let Lila will back me up if I don't have the facts. So as far as I know, it's version 1 at this point in time.
Yep. Yes.
On this
Just
one.
checked.
And then the effort that we're going through on model retraining is to move it from a TensorFlow based system underneath to PyTorch. And so on that, we'll have, MobileNet version 1. Hopefully we'll get version 2 out, and then we'll have YOLO coming out later in this quarter or earlier in Q2. So no later than the end of April would be what I would say right now from what I can see on it. So the other thing we do support is RCNN too on it. So we have 2 models, version 1 and on the SSD and then the RCNN one. So
Sweet. And then we have a hello from Shazib. So hi, Shazib. Welcome to Hacky Hour. So from here, Steve, I believe you have a presentation, and I can pull this up and let you.
Yeah, that's why I give it to you, because you're much better at it than I am. So as Kamal said, what we want to do is, last week we had open office hours where we just kind of fielded all kinds of questions, and we always want to do that at this one. This is a hacky hour. It's not a webinar. But at the same point, we want to do some content and so forth. So it's a new year. What we want to do is go through the starter apps on it. And then next week we have up on our GitHub, we have a lot of content. And so what we're going to do is start to put a content calendar, start to look and use some of that content on these hacky hours, but also add to them. So it's not what's there. And so we have something called Video Streamer up there right now on our GitHub. And that shows you how to use the Flash server and how to stream our applications into a web into a web page and so forth. But we want to add to that. There's other types of software like Dash and things like that, Lila's built some stuff out for our customers and things like that. So we are going to add on top of that. So Lila and Eric will have it next week, and we'll start to add that. But also, this is the community forum. And as it is the community forum, if you just Discord us if you want to show something as part of the community and so forth. So last year, AB came out and did facial recognition and so forth. So we just encourage that. So come in, if you have something you want to do, it's also your time, and that will, can preempt what we're doing on the content calendar. But that's, that's it. That's kind of the intro piece. So we can talk about starter apps now. And so part of what we've done within slide 2.
Yes. Yeah, so before we move forward, we do have a question.
Okay.
Yeah. Can we control GPIO ports of our edge devices with the help of alwaysAI?
So one more time, sorry, just for everybody's, I'm on the central coast of California, and we're getting the rain. So what I've said is you may lose me just because we were playing power outages and things like that. But so you got garbled a little bit, so Kamal, so go ahead.
So can we control GPIO ports of our edge device with the help of alwaysAI?
So not with the help of alwaysAI, but with the help of Python and the strong community within Python. There's a couple of GPIO libraries in there, and you can put those into your Edge IQ systems and control. I will tell you that when we have Pi Day, I forget what Pi Day is coming up, we'll have some fun with that, right? And we'll demonstrate that. Definitely, but you can use those libraries and build them into your application. We don't prevent you from doing that. So
yeah, and there's a suggestion.
I'll let Lila gets this one, so go ahead, Lila. Sorry, Lila's been involved in getting some of those libraries in there for people. So
yeah, there is an app I just put in into the chat answer that uses GPIO 0 to get the internal temperature out of the Pi. So that's one way. I think the other one is like a R Pi 0. There's a couple. So you just put them in the requirements.txt and you import them in your app.py, and then you should be good to go. If you have any problems, you can always ping us on Discord and we can.
And then, Lila's a very good Python programmer. Okay, so that I want to add. So for those of us who like to break the rules, you can also do a run command in the Docker file. Just
That's
don't put
true.
sudo, and it will install the applications there. So you can either use a Docker file or the requirements.txt file. And by the way, you still have to launch the requirements.txt when you're in the Docker file to get it to install. So
That's true.
Yeah, and that's exactly what AB suggested, that you can add the Pi GPIO file into requirements.txt. And then there's another question here, which I think you're going to cover today, Steve,
yeah.
is how do you create a custom alwaysAI project?
Custom. So I hope most of them are custom. So can we get a little bit more detail on that one? I'm not sure, unless Lila, you already know what they're asking on that.
No, I think some more detail would be good.
So basically, alwaysAI is to help. It's a computer vision, and to help you kickstart it, we have the ability to deploy to different platforms. We have middleware components that run across the different platforms you're going to see on the edge. And then we have a system to help build MobileNet SSD models right now in object detection. That's pretty straightforward for any user to use. They don't have, it's not required any advanced programming techniques and so forth. So on that. So that's what I can tell you. We'll talk about, but so you can customize any of these starter apps that come up and make them into your own personal project. I'll even show how you can even rename the project rename the application you're starting, because I see that sometimes. We use something called app.py, and I'll show you how you can rename that if you wanted to like bob.py or anything like that, and still be able to run it within in our system. So I hope that it answers the question. If not, let's have them come on and ask Kamal.
Yeah. So obviously,
this is a regular development environment. Bring your own IDE. We have a lot of diversity in IDEs ourselves in this company, so we welcome everything. So almost everything, but yeah.
Yeah, obviously, if you'd like to clarify your question, just raise your hand, and we'd be happy to help you out. Okay, so next slide.
So the next slide is, let's do an overview of what starter apps are. So what we intend the starter apps to do is ease your way into application development, so that you don't have to start with the basics, but to try to jumpstart your projects and your applications onto it. We have starter apps. The other thing we wanted with the starter apps is to demonstrate how to use APIs around different categories that we have, how to use different peripherals within those starter apps, and then how to use the different accelerators. And so oftentimes you'll see within computer vision, you can run things off a CPU, which, is okay if you're in an x86 platform. x86 platforms have been designed architecturally to make CPU execution okay with computer vision. But some people, as you get to edge devices, the edge device may need a little help. And also with this will help outperform a lot of the x86 systems. So there's things like NVIDIA's CUDA system that's out there that's able to multitask between the CPU and the GPU. They're big GPUs. There's other things like Intel's Myriad processing systems, which are low power, but what you're going to do is offload the model inferencing onto those systems and away from the CPUs. And we support both the Intel Myriad accelerator and NVIDIA's GPUs. Now, last week as it came up, we don't support the Coral at this point in time, and I don't foresee us supporting the Coral. So next is, what Komal showed you was the way that most people will be introduced to starter apps, initially, and that's they come on the web. And they come on the web, and they, you'll either start up in one of our major categories. You can get a starter app in object detection, classification, and so forth. We have a second way, and we're going to share my screen. I'm going to show you. We have a second way, which is the CLI. And the CLI will bring down, 15 different starter apps on it. So with that, why don't we get started, and if everyone's okay, and start to do some hacking around, right? That's the way to put it. So let's hack. And so I'm going to go ahead and ask for the screen at this point in time from my colleague. Okay, so are we doing okay? Am I actually sharing my screen? Can you see it? Thumbs up or something, Kamal? Do you see?
I can see the dashboard.
Yeah.
Okay, we got it. All right, so anyway, so let's go ahead and let me bring up my bash. And so if you type in, so one way to know all of our commands is I have the CLI, my internet connection's unstable. That's interesting. No, I just like the terminology that we use in error messages. Psychologically unstable. What is it gonna, what does it mean? But anyway, sorry, back to what we're doing. So if you look at it, you just type in alwaysAI, it shows you the different commands. And mostly the commands are divided between model and application. So you see an app and a model, and well, data set annotation. It's divided lots of ways. I shouldn't just say that. User functions and so forth. But one of them, and if you highlight, is this get starter application. So if you want to download all 15 of the get starter applications, you just simply type in that command. And what it will do is download a bunch of stuff. So this is really, so I apologize if on this one, it may be a little bit slow because I'm tapping both running here on the video conferencing as well as Zoom here and then getting this, but that was fairly good. That wasn't bad on that. So what you get is you get a whole set of apps. So let me go in and actually go in. You'll get a starter apps directory, first of all. And so let me go over into that. So I'm going to go over to alwaysAI starter apps, and I'm going to come in, and you'll see you get a list of different applications. So let me clear my screen and just so you guys can see better on it and get rid of some of the noise. So come in, you can see the set of 15 different applications. So come on, I'm sorry on this type of stuff, but can we flip back to my slideshow and we'll start to go through these. We're going to be flipping back and forth between slides. So apologize on that. So next slide, let's go over and it starts to talk about some of the uses. So basically we break it down into what we call categories, and the categories are roughly going to be classification. And then we have a whole slew of things in object detection, and then semantic segmentation, human pose, but we also have the trackers, which we talked about too, that are in there on them. So if we look at the first one is classification, and so what classification does is it tries to find the predominant feature in an image or a frame that comes through, and it then tries to classify that, and it'll have a set of results, top results, and the next 5, 6, and 10, whatever you want to do, it will attempt to classify it. You know, what is that good for? Well, you know, we had kind of discussion, AB and Lila and I were talking, but one thing that classification can really help them on is reading medical slides. So if you think about if you have a slide, you can tell, does it have malaria, cancer cells, and the CDC and all these different things have data sets which allow you to go in, and they're all over World Health Organization. They have these sets that you can build these things. And if we look at like our current situation, yes, there's COVID, but think what COVID does to a situation. So if you have these labs and lab technicians, they get overwhelmed looking at whether somebody has COVID or not. What about the other diseases, right? So what I think that classification can really help on in these types of situations is automate that lab technician's job, take a look at a slide and then classify it and so forth. If you think, you know, we have COVID now, but a lot of times in areas like malaria comes out and becomes strong and things like that. So I think classification can really help an overwhelmed healthcare organization and things and so forth. So that's just kind of my take on what classification can help on. But let's go ahead and let's run an app. Let's just do the basics. So I'm going to go in and I'm going to take one called image classifier. And what image classifier does
Are you sharing your screen, Steve?
I'm not sharing my screen. See, that's why we have to remind me of this. And this is not the first time I've done this type of thing. So let's go back. So now we should be back to sharing screens, right?
Yeah.
So we'll go ahead and we'll go into image classifier, and let me get the context of this thing, and we'll go to image classifier, and we'll come right in. And the first thing you want to do to run this application is come into alwaysAI and do what we call an app configure. And so Kamal's showing you how to set it up and do it from the website. I'm going to do it from the command line. So what I'll go ahead is I'll run this alwaysAI app configure. And it's going to come in and ask me some basic sets of stuff. Do you want to use any of your current projects? Nope, not really, because that will wreck the rest of this presentation later on. So I'll come in and I'll say, yeah, let's create a new project. And then I can enter the project name, and I'll just call it a classifier, right? So now I have my project set. And so then it's going to ask me the next question. So it's going to create some of our basic files and so forth. You know, project file, an app file, which has app information, and then it's going to actually download it found the starter app because I already downloaded the starter app when I did that CLI command. Then, you know, I'm going to run it on my local computer to begin with. So we'll come in here and do it. So that sets up the project. If I were to go over to my dashboard now and take a look at projects, and there we go. So we see all of a sudden now, even though I was working on the local stuff, it's going to put in the classifier project that I just created on my system. It's going to get that information and generate it back to the web. So see, it's there. And then what I wanted to show you quickly is if I come in, remember names. Okay, I do always, and it should do that. And then I'm going to do apps. And I did want to show you this app thing, JSON. So a lot of people, some people say, I don't want to call it app.py. This is where you can actually change the name to your project. And if you want to do like a lot of people, if I wanted to call it classifier.py, I can put it in there. Also, this has the models associated with the project in there. So this gives you basic app information, and you can go ahead and modify it like you can any JSON file. If that, you know, as you become more senior or not senior, more experienced at using alwaysAI, you can have fun with this thing and add it yourself and not have to go through the system, knowing as you change it, it'll get replicated back up if you run the configure command. All right, so we've done the configure command. The next thing you want to do, and Como showed this is all the same, you're just going to do an app install. And what this will do is build the environment and get everything ready, add your application, get everything to run. Boom, it sets up your virtual environment, goes through, and then, you know, when Lila was talking about the requirements.txt, this is where it's going to exercise the requirements.txt file on the system. So if I had anything loaded in my requirement.txt and so forth, this is where it's going to execute as that last file. So boom, that's it. So now I have my first starter app going, and it's going to be around that. So I just have to click and start. And boom, that's how easy it is to get started. And what this one does is it goes against a set of images that are out there. So it's running, it's going to show you, I'm going to classify everything from a black bear and so forth. And people do like to tell images, because if I try to do this, you know, within my office, I'd have to go get a black bear, put it in my office to classify and things like that. So that's why a lot of it's done through image sets and so forth. All right, so let's say I wanted to run a classifier in real time. So we're going to go take a look at that, and then we're going to run it from an edge device. So I have a little section called Beyond the Starter app. So I want to focus in on neglected classifiers, and I want to take a classifier into real time. So and I'm going to bring a bear into my office. Not really, but we'll go ahead and take a look at a classifier in real time. So let me come back, and I have a set of applications, and we're going to deploy to edge devices now, and we're going to take a look at accelerators as the next step of writing that real-time classifier. So let me go back, and I'm going to go into my Beyond section, Beyond Starter apps. inspired by Beyond Meat burgers for those on it. So let's go into a real-time image classifier. And what you'll see is we actually don't have this in the starter apps. Everything's kind of going off of, oops, sorry, it's image classifier onto that. So let's go ahead and take a look at that. Let's see what's going on. So we're going to pop this, and it's really good because it also shows the structure of a system. So alwaysAI is object oriented. And so the first thing you're going to need to do is come up here and import. I'm going to use some computer vision pieces for image manipulation on this. So I'm going to import CV2 on this. So what's important is part of our middleware stack that we have, not only is Edge IQ there, but we have, and it runs across your x86, your ARM platforms and everything like that. We have OpenCV as part of our system. We also have another one that's called dlib that's in there too. So we have two of the more popular computer vision, open source computer vision platforms in our platform that allows you to use things and so forth. You can, I'm sure that Lila will show you how to use SciPy and other types of things in there on the stuff. But we also have NumPy, I should say. You know, we have a lot of the popular things you're going to want to do. So that's the first anatomy, is you need to make sure you import whatever you're going to use. At the very least, you need Edge IQ imported, and that is our Python libraries, our proprietary Python libraries. The other thing is, because I just want a performance benchmark, I'm adding time. So I'm going to take a look. I want to know about FPS. I want to know about duration, things like that. This is more for my troubleshooting. So I'm importing the Python library time into there. I'm going to use it. So let's go into the main function here. And again, you'll see as we look at semantic segmentation later on, if we looked at object detection and so forth, we'll probably look at object detection. We do everything in objects, and within that, and you can see it in our docs, is you're going to want to import, in case of semantic segmentation or classification, let's say the classification object, and part of what, and then call out what model that you want to use. And we're going to use a classifier called Google in that today. It's a pretty good one on it. The next thing you want to do in the platform and the anatomy is, okay, I want to run my engines. And your engines are your inferencing engines at the end of the day. And we have several. The first one that we support, the first one I'm going to use is our internal CPU engine called DNN, right? So I'm going to use that engine to start with. And then this is just for me. And we put this in here as structure for everybody else. And we want to know, as we load this, we want to know what engine we're using. And then part of this engine is also an accelerator extension. We're just defaulting to the OpenCL GPU interface to it right now on it. So we're using the default and the accelerator. But on this printout, I want to know what accelerator I'm using. I want to know what engine I'm using. And then, you know, I also want to know what model I'm loading and the labels associated with that. So that's why these print statements are here. And then I want to know how fast it's going on frames per second. So again, I'm coming in and we have a toolkit as part of our section that have an FPS system on it. So hopefully I haven't lost everybody. I know this is pretty basic, but we'll have some fun with it. Any other questions at this point in time?
Yeah, Steve, if you don't mind, let's stop for a
yeah, sorry, I can get gabbing. So
no, that's okay. Okay, so the first one is, is it possible to access my Edge device and its web interface, the local host, if my Edge device is deployed or placed in different cities?
So the answer is yeah. When you say it's web device, yeah, there's ways to do that. But common way that you're probably going to want to do is a streaming video session across, and that's what Lila's going to cover. Now, you need bandwidth to do that. That's always the thing. So if you want to visually see what's going on across cities, what is it, RSTP, right, Lila? We have that interface within our code. And here she comes.
Yeah.
Hello, Lila.
I think that I always get my acronyms backwards and mixed up.
Me too.
I think that is. There's a few different ones. Tyga is really good with that sort of stuff too. So maybe we can ask him to join that one. There's like IP video streaming and RTSP. So yeah, I think there's also, I mean, you could, if you're using something like Balena, that will let you view the output of an edge device. We did that on one of our Hacky hours a few weeks ago, where if you have your edge devices deployed in different cities, you can view them using the URL in Balena's interface tube. That's a little bit more work, and it's not really like a custom GUI that you're talking about in that way. That's just deploying an app in a different location.
Yeah, so you can use Flash servers and things like that to bring things back. 0MQ would be another way to bring it back from a central site and so forth. I don't, and so, yeah, you can stream those back. You can set up your edge devices and come back to an x86, more of a fog environment to do those types of things. But you can set those things up to so what Lila's going to show is you turn your device into a web server and then pull back and be able to see that next week. So you can do those types of things. That's exactly what you can even use the streamer. Quite frankly, you can use the streamer to see remote devices. It doesn't have to be there. If you are going to use, and I get, again, like you, I get my acronyms mixed up. If you do use the streaming video service, and it is in the docs and so forth, I think, let me kind of flip out of this and go to docs, right? Let's go to docs for a second here. And if you go into EdgeIQ API and you go down to, I think it's your video streaming right there. You can see we have different ones. And if you come in, GStreamer and things like that to hit, but you have, and Jetson, but you have an IP video streamer. And the IP video streamer, all you need, you can build your application and turn your edge device into a streaming camera system. And there's ways to do that. There's that you can look up on the Pi and other things. The only thing that I know that you have to have when you put in the TCP IP address is the TCP IP address has to be fixed. You can't use DHCP on this. Otherwise, when the address changes, it won't recognize that camera coming in. But that's all built into our utility. So yes, you can have it multiple ways of seeing what's going on in your edge devices. The Balena piece, you do have to load their OS. Anytime you use Balena has a customized OS that runs on different edge devices to get their services. So, all right.
And Steve, I'm not sure if you intend to cover this today, but this question is specifically about making the CLI work on the Jetson Nano. So I think it's deploying on the Jetson Nano. The question is, how do you get the CLI working, which I think is how do you deploy on the Jetson Nano, or does it work on Windows only?
No, so basically it works. So the CLI works across platforms, as Como showed in her introduction. You can put it onto it. So there's a couple ways to do development: directly on device, in which case you're going to follow the Linux instruction set and you're going to put it on your Jetson Nano, and you can just sit there and have your keyboard and work on it and so forth. Or you can do a host to edge device. And today we're going to cover host to edge device. So I'm going to develop on my Mac system, which CLI executes on and everything, and I'm going to deploy to edge devices and run stuff on the edge devices. But if you follow the Linux instruction set and set everything up, you can use your Pi or your edge device. It would be Jetson in this case. Any Debian-based OS system that's out there on the edge, follow the Linux instructions. You can do that. The only thing is that when you work on Linux, it's command line oriented on our installer. There's not a real true installer in sense, and you're going to have to set up your Docker and any type of edge device. You're going to have to set up your Docker, except for Jetson Nano, which comes with a Docker system on it. So, or any of the Jetson devices, I should say.
Sweet. And then do you need a static IP while running your edge device from Windows?
No, that piece you don't. So it just depends how you set up your router and so forth. If your router is going to use like a host name, you'll be fine and things like that. So I haven't set up my router right here at home. So I'm IP device dependent. So I have to have the direct IP address. But no, if you can do host names as it moves around on the DHP system, it doesn't have to be static.
Okay.
Just how your router resolves things.
Okay, and the next one is, can we access alwaysAI through SSH? And can we transfer data securely over, it says far transactions, but I think over remote connections?
So the answer is that's what our CLI sets up. But I think probably maybe the essence of the question is, can we get things off the device and back? And that's we got an expert here that does that all the time, and how she builds it and so forth. And Tyga also, but Lila's been working with customers on that, how to get things back, and we hope to get her on a webinar doing some stuff around COVID and things like that. So with that question said, let me get Lila in there and talk about on this subject. So
the image capture dashboard, the newest version of that one on GitHub, will let you download stuff from your edge device to your local device. But yeah, I mean, you can always secure copy files from your edge device, or as SDP using SSH. But yeah, you can also work it into a GUI that like uses your Pi IP to then copy the files over automatically without you having to, go open a new terminal and SCP in. I think we have done a Hacky Hour on the image capture dashboard, so you can go on YouTube and look that up and dig around on the code on GitHub, and then ping us on Discord if you want a more specific use case, or if that didn't really answer your question. But yeah, you can definitely get files across. You can interact. You can look at that image capture dashboard. Also lets you view the files and manipulate them and then delete them off the device. So there's lots of ways to get around that sort of thing.
And I think there's a clarifying question on that. How can we access, control, and access edge devices securely through SSH?
Yeah, we're trying. So anything SSH it's secure. It has the known host, but the CLI uses SSH just so people know. But how do you access it and so forth? It's a complex question. I mean, if you have a runtime environment and like you're bringing it up, let's say in a true runtime, and you're just starting the container and things like that, you have to have the right holes in the container. You have to do and to bring that out. And again, we can help you with Discord on that. It's all possible. Whatever you can do on Linux and so forth, you'll be able to do on our system. So you can set up a RESTful API system that brings across and encrypt your HTTPS. You can also, again, like I said, you can build in some secure file transfers and things like that. But the CLI is an SSH system. And that is how we're accessing and developing the system. So it's all secure, has to be a known host to the system. You can't do a man-in-the-middle attack on us and things like that. So it's following that. So.
Okay, and another clarifying question is can this be done even if the edge device is located in a different city?
Yeah. You're just going to have latency. Right. And on that, and you're going to have to, so just like you can SSH into it and so forth, you're just going to have to again, it's all about, can the router, like if I'm in a private corporate network, yeah, my router probably can resolve that host thing. On the internet, that might be a little bit harder, but it has to be able to resolve the host on things. That's, as long as the backbone's in place to resolve that host, you can work remotely.
Great. Okay, and then and this one is I believe this is based on the earlier presentation I gave. So it says, you mentioned Docker. If you're running on Pi or Windows, will you need to install Docker? And do all executables of alwaysAI run in a Docker virtual machine? And so my piece, when I deployed it, I didn't need Docker because I was deploying it locally. But if you are deploying it out onto an edge device, you do need to use Docker. And Steve, feel free to add on to that.
Yeah, so we are a Docker system for the most part, except for when you're working on Windows and Mac, because we all know how much Windows and Mac love Docker, not. So, but on Linux-based systems, we are a Docker system, and you have to have not only the Docker, but when you put it in, but you also have to register your user in that Docker. So a lot of times the errors we see up on Discord is they haven't gone through and put the user level in on their container on that remote device. Docker comes pre-installed on your Jetson devices, so you don't have to worry as much about that. You just have to make sure your username is part of that Docker system and go through that.
Great. And then one more question, which is just an ideating question. How would you go about creating a solution where you could solve a Rubik's Cube using computer vision and alwaysAI?
Oh, yeah. I haven't really tried that myself. I see it out there a lot on that. I don't know. I'd have to defer to somebody that's gone. I don't want to. I just haven't looked at that problem space, but I know it's been solved a ton of times on it because it's one of the favorite things to do on LinkedIn. So maybe, I don't know, Lila, AB, if you're out there, maybe you've taken a look at how to solve the Rubik's Cube problem.
I've just seen it on LinkedIn. That's yeah. I could guess. I mean, I could guess what they're doing, but I have never tried it myself. So yeah, if AB has ever tried it, he's tried lots of cool projects. Or if anyone else from the team is on.
There we go. Hey, AB.
Hey, AB.
Hello, hi. Yeah, that's one of my that's what it's in my wish list for sure. I really love that, but I wanted to do it with a copot, to be honest, like not with doing by hand. So yeah, that's one on my list. But the thing what they do is they do the first color recognition. So there's a lot of control environment you have to be in. You just cannot do it in front of. It should be in like a proper lighting condition, proper background. So because when you're doing with your hand also will be like there will be a lot of color contrast. So we have to use hue, saturation and value. So you have to convert the RGB image into a hue, saturation, value, and then identify the colors. So mostly I think there are 6 colors there. So you have to identify ranges for each colors. And there's an algorithm. I'll put it on the link there. There's an algorithm already there which somebody has built, and it is a Python library. So you have to just pass on that colors when you see that face in front, and then it will give you what should be the next instruction, how the cube should be rotated. So that way you can build that. So that is a typically it is a solved problem, but there's no like a full solution with OpenCV out there, but there's an algorithm already there. So I will post a link to the algorithm and try to write something. I will try to post it on Discord, so that will be easy for everybody to access.
Okay, thanks, AB, on that. And so what AB is coming into is you have a classic scenario, right? So you have machine learning based computer vision where you train a system. And so what AB is saying is part of this algorithm depends on what we call the classic system, where you have to craft a solution. And you'll be running, and again, we have OpenCV, so you can convert into your HSV color stream. And what he's saying is you're going to have to craft that HSV to work in the lighting conditions that you have and to focus in on the colors. And maybe correct me if I'm wrong on that, but that's the way I interpreted what you were saying.
Yes. And there's a nice webinar, I think, Steve, you did it about HSV and all those formats as well. So that's if somebody who is not familiar with that, it is good place to start. So HSV format really helps you to color capture and all that compared to RGB color space. So HSV will give you good for, because whenever you have any use case where you have to pick up the color, HSV is the way to go.
Right. So what HSV does is that you know with RGB you have 3 channels: red, green, blue. And what you try to do within that is you're blending different versions of red, green, blue, those 3 channels, to create the color. But what's happening with those RGB channels is you're going to have elements of as you change around, you're going to have elements of black and white in those systems. So if you go to HSV, what it does is it has 3 channels, just like RGB, But on those three, it has hue, which is we generally think of that as the color, and then saturation, which is how much white is in the color, and then value, which I think is how much black's in the color, and on that piece. So what it does is start to split out those different things, because you'll understand if you look at a color wheel in HSV, this is where the hue is, but it's really the saturation and value that could vary on you. So on those, and it's going to be, well, maybe we'll go back as we train. Like AB said, I did a little bit with HSV last year to detect an LED light. We'll come back in, and I can do some in a further hacky hour on stuff where we can spend some more time on HSV types of stuff on that. So maybe I'll take a look at what he has, and maybe we'll do some Rubik's Cube solving. So that's a good hacky hour. Or if somebody does it ahead of time, let's let you come in and do that, community, based on what AB is going to share on Discord. So anyway.
Yeah, I will share something on Discord. I will try to write up something so that people can follow it, hopefully. And if somebody solves it, it will be very good. Yeah.
Okay. Thank you, AB. Appreciate it. So we have one more question.
Okay.
It's from David Dodds, and it's, does the object detection process use optical flow to detect objects that are not already in the labeled object library? And what is the correct way to detect and quote see things?
Yeah, I think optical flow for me is it's model based. I think Sache was talking about that this week. I haven't read his article on it and so forth, but there are certain models that use the optical flow technique, and I don't think right now the object detection models we have are doing that piece, David. That's good question. I gotta see what Sache was writing and see if we can get some of that in, and maybe that's a hacky hour too. On that.
Great. Okay.
Kind of a dodge to his question, but that's where we're at right now.
Okay. All right. I think we're ready to continue, Steve.
Okay. On it. Obviously, the questions are not about what I'm doing. So maybe this is just self-entertainment right now on this. But anyway, I just wanted to give the structure on it. So, and what Edge IQ did. So we have within our tools, we have the FPS piece. We've loaded, as I said, our model and our classes and so forth. We also have within, we just saw this because of the questions, we have different ways to interact with the camera systems, be it a streaming camera, be it GStreamer itself, which is a Linux and Unix technique to cameras, and many of the people that do CSI cameras, it's the only way to interface. And the CSI, those are the ribbon cameras that you often see come into devices. So we have support for that. Jetson has its own type of camera system, as well as working with webcams for its CSI interface. We have that in, but this one we're just going to work with generic old webcams. And so you go in and you load the API here, and you determine which camera you're going to use. And since I only have one camera up, I know it's camera 0. That makes it easy in life. And then I give it a little rest to come up the camera, and then I'm going to start my FPS. And then most of the work is done around a while loop. So if you look back at the one we looked at, there's going to be, how do we go through an image set, and that will show you that. But we're going to look through the camera. The camera is basic on this while loop where all the work is done. You're going to read in a stream. You're going to pump the stream. If you remember, we set this up as classifier. We're going to classify the image. That's the action method within the classifier object, and we're going to do that. And then we're going to get back a whole, we're going to start building up some text to put on the streamer, right? So I'm going to go ahead and get the model ID and get the duration of time. So I'm stamping out that information. What is the model? How much time am I spending on my inferencing, so I can understand different edge platforms is what I want to use that for. Then we're going to go through and do we see any results from the predictions? If we don't, we're just going to drop down and put no classification, right? So this is the first big if statement here. See any results from the classifier? Okay. And I think, so let me go back. And then if we do, and again, we return a results object on everything. So within that, so if we see some predictions, we're going to go through and we're going to add what's the top prediction. So we love NumPy arrays here at alwaysAI. So our predictions are in NumPy arrays. And so what we're looking here is the first thing in that array. So we look at in the predictions, the label, the first confidence level of that. And then, you know, we're writing out to the frame itself. So we're going to put text on the frame. And that's what OpenCV is good at. Sky Image is also good at that one, and you can import that library. We don't have it built in, so you're going to have to add and put that library in via our famous requirements.txt file or our run command. And then what we're doing here is just adding the text, and then we're going to loop through some of the other indexes and predictions in the system. And then finally, we're going to come out and we're going to put everything up on the thing. We're going to update the FPS. We're going to put it to the streamer, and we're going to check to see if somebody wants to execute the streamer. I mean, leave the streamer, exit it. So anyway, that's basic anatomy. So let's go ahead and have some fun. So first thing I'm going to do is come back to my system. And then what I'm going to do is do the configure. And we're going to go and we're going to run on the Jetson Nano to begin with. So I'm going to run it on the Jetson Nano, and I'm going to run it on the Jetson Nano CPU. Then we're going to go ahead and add the accelerator to the Jetson Nano. And we'll see how that picks up. And then after that, we'll do some various degrees. We'll take a look at floating point 32 first, because that's the default on the Jetson Nano precision of the GPU. What's it looking through on floating point 32? And we'll talk a little bit, then go 16. Then we're going to go off and we're going to go to a Jetson. We're going to go off to our famous Pi device, and we'll see how that works, and we'll add an accelerator to that. So that's the game plan, and we'll show you how to do that in the code and redo it. But first, let's start, and let's just go and go ahead and do my app configure. And what the app configure does is it allows me to target where I want to do my development, which device. I'm going to use a remote device now this time. So I'm coming in now. I have a saved device, and when you're doing demos, you always want to have saved devices, right? So you know it's going to work. So I'm going to use one of my saved devices here. And what I'm going to do is go to the Nano Temp, which is there, and head off to that device that I have set up. And as you can see, it's going to connect through SSH, one of the questions there, and it's going to check to see if I've set up my Docker correctly on that system. Do the Docker executable there? And if it's not, it's going to bill out an error on you until you got to go load the Docker executable on this platform. But it's there. And then it's going to find out, do I have permissions on it? And that's what we talked about. Is my user ID part of the Docker user IDs on that system? And the answer is yes in this case. And so then I'm going to go ahead and I'm going to add the directory that I want to put it into, and I'm going to get all that information into my my target file and my JSON file. So I've done that. So now everything's working fine. So now I'm going to install it onto the device. So I'm going to come in, I'm going to install it. And so it's copying the application to the target. And then what it does, and some of you that might be running through some of the demo apps and things like, gosh, it takes a long time when it hits this step right here. Well, we maintain everything in a Docker image, like we said. So what the system's looking for is, do I need to update the Docker system and so forth? So sometimes it will start pulling stuff down if we've done a release and so forth. And that can take some time as it pulls it through, but it updates and gets it to the right level. Now, if you looked at your Docker file and you don't want it to do that, there's something called a Docker file, which we've been talking about on it. So let's take a look at it. If you want to, you can go ahead and pull out this out and actually put it to a dedicated system, so it won't automatically update if you want to on this. So you can change this around and hard code it, and we have documentation on how to do that and so forth. So if you're developing a real application, you're saying, you know what, alwaysAI, I don't trust you right now. I don't want you to update my Docker file because it's my Docker container because it's working just fine. You can hard code it in this file. This is also where you put the runs and other various commands that you want to do. Docker commands is into this file. So anyway, so let's leave this on that. So we've now we've done our install. So now let's go ahead and actually type in the correct thing to do, and we're just going to do our start command. And this is the system we saw. This is going to be a real-time system. and it's going to bring it up. And what I'm going to do is I'm going to come over here to this, and I'm going to say, okay, what do you see? Well, it's finding my water bottle. Okay, and so that's it running on the CPU of the Jetson Nano. So what we see is it's inferencing about 230, around that range, a little bit more, about 235, let's say, on average on the thing. It's bouncing around, but that's how fast it's going from inference time. See my hand? It's not bad. That's all on the CPU. We haven't done any acceleration. Hi, people. We can see me waving and so forth. So that's it running on that system. I can see how fast. Looks pretty good for an edge device, right? And it's doing classification real time. So, but let's go ahead. Let's say, you know, I want to speed this up. So what we have in here is we have the ability to do that. We have a section called, if you came into my documentation for APIs, I have, if I went into object classification and I wanted to take a look at the different things going on, I can see we have this command engine and accelerators. And we see these down here. So if we come in, we can see what different types of engines we have in the system. And one of them is the CUDA system. And that is NVIDIA's big thing, is CUDA. And what CUDA does is it allows the CPU to call the GPU and schedule things with the GPU. And it really combines the two, CPU and GPU, in a fabulous multiprocessing system on it. It's a great piece of software from them. And we're running on a Nano, so we know it has CUDA. And so we're going to go ahead and implement CUDA. And we can see it has two accelerators in the NVIDIA and the NVIDIA FP16. And so let's go ahead and do that. So to access that, the only thing I need to do in alwaysAI is simply type in that device. Now, I also want to add my accelerator. By default, it would go to the 32-bit accelerator, but I want to show that parameter too. So we're going to come out, we're going to add accelerator. We need to reference that it's part of Edge IQ. And then we'll type in, I think we have to go big accelerator next on it. And then the last thing I want to do is add in, I think, Nano. Let me see if I remember these things right. If I don't, oh no, excuse me. I think is it equal or no? We'll find out. I'm going to error out maybe here. It's been a while since I've done an accelerator. So we'll see how bad I am on this. Should be it. Did I misspell anything? Let me check.
Oh, I think you just need a accelerator equals.
Did I not put the accelerator equals? Oh. Thank you, Lila. There we go. Is that what we need?
Oh, wait.
No, sorry. This is right.
That's right, yes.
And this is wrong, because you can see right over there on engine what I need to do. So for everybody, that should be it. I think I did NVIDIA right. Yeah. No, I didn't. NVIDIA. So there we go. That should do it, right, Lila? You see anything that's gonna hurt me? So the only thing that can hurt me is not saving at this case.
That's true.
So now what we're gonna do is we're gonna use the NVIDIA accelerator. And it's that straightforward. So I'm gonna go ahead and I'm gonna reinstall, because I've made changes to the application. Anytime you make applications, you need to reinstall it on the device or your virtual environment that you're running if you're running on your hosted system. So I made changes to my code. I'm going to copy it out. And then we're going to build everything out again. So it's working okay so far. And then we'll do a start. Now remember, we were running about what, 235 milliseconds? Como on the last one on inferencing just on the CPU. So let's go ahead and see what happens when we combine the CPU and GPU and use that CUDA interface. And there we go. Now we got a real-time classifier up. And I'm going to go back to not playing this game with the system showing me. And so let's go back and look at it. So we're going to come back and hopefully it hasn't crashed on me. Okay. There we go. So now you can see this is what the accelerator actually does to it. So it makes it run at close to 50 milliseconds and so forth. And if you look, I think this is going to be clocking up near 20 frames per second. And how we measure frames per second is that's after you do all the manipulation. It's not, you're going to see NVIDIA actually put out a lot of things like, hey, we run at 60 frames per second, which always gets interesting to me how they do that when a lot of their cameras only run at 30 frames per second. So you're going faster than camera, which means you're probably inferencing things twice. But they also play another game where they come in with a zero loaded image and so forth and to speed it up. So when we show FPS, we're showing the actual, this is the FPS, we're showing what it takes for a total application to go through the FPS process. And that includes kicking it out to my screen you see right now. So on that. So I just wanted, because we get a lot of questions on Discord. Why is my FPS slower than what NVIDIA is doing? Well, NVIDIA is like any company with hardware. It's going to speed it up in its tests, do little things. So
yeah, and Lila also posted the Hacky Hour that we did with CUDA. So
yeah.
if you're interested in learning more, definitely check that out. So
yeah,
Steve,
so it's got a whole bunch of stuff on it. So on that.
Yeah. So there's a question here that says, how do you set up the Docker for the Jetson Nano?
You don't have to. The Docker comes down as part of the Jetpack. So it's already there. The only thing you have to do is add a user. Lila, I don't know if you have that command on add user. You always remind me on our internal Slack channel when I get an error on it.
Yeah, AB's reminded me on Hacky too. I'll look it up, but I think it's sudo user mod dash lowercase a uppercase G Docker $user. I'll look it up.
Yeah, so we're going to get Lila or AB or somebody out there in the community to put it up there, but there's a way to do it. We also, if you look at our, like if you need to set up a raw Pi and bring down Docker, inside our blogs, we have setting up a device. And well, not even in blogs, inside our actual docs, I think we have setting up a user device. So if I get, I think in getting started, right, there should be Hello World,
yeah,
the computer setup, and it gets the edge device set up too.
Yeah, I think we've moved things around. So now
there's
the AI workflow. There's working with edge devices.
Yep,
and then so in that one, we've updated, and we did have a user on Discord, and I found this out the hard way the other day. You need to have Jetpack 4.4 right now, not 4.5, because NVIDIA just released a new one. So make sure it's 4.4. And then we do have links in the docs to some extra blogs where Andres has shown you how to set it up. Here's the blog that does like a more step-by-step, but all the stuff you need is in the docs that Steve's showing right there. So there's that. And then there's some other edge device setup ones on our blog. Steve even has one about how to set up a Pi as a development machine if you want to run it. So you can, all these questions are really great questions. And if you dig through all the stuff, there's lots of blogs and docs that will help, but it's good to just mention them here. Yeah, don't use 4.5 just yet.
On the things, use 4.4. And the reason is they change out their drivers and so forth. So what will happen is, the drivers that we're loading in everything into a container may not be compatible with what they do on the lower Jetpack. So we are at 4.4 or 4.3. 4.3 will work fine also. Those two are very compatible. 4.2 will not work on it, but 4.5 just came out. And so we haven't had a chance to really take a look at it and see what's going on and so forth.
AB says there's some lib issues too, so that's good.
Okay.
Hold off a little.
Yeah. So that's what I love about the community is people like AB are out there taking a look at this type of stuff, and we'll be as responsive as we can on Discord and trust it makes a development card when we see these hits. The last thing I wanted to show you is really and kind of play with the Jetson platform. And do that is, let's go to floating point precision 16. So what we've seen is floating point 32. And so it's how big the integer is going into the GPU for processing. This one tries to work with floating point 16. And you're going to see an interesting thing here. And what will happen is, let's go ahead and do an install to it. And this is going to happen to people out there. So the idea of floating point 16 is less data, faster, right? And what I'm going to prove to you is that's not always true. And you have to be careful as you look at the situation. And I would recommend, as you work with NVIDIA devices, you start at 32 precision and you go to 15 when you're working with what they call the CU, the CUDA DNN, which is their backbone libraries on it. So if we go to this, and then we'll take some questions. I can see them coming up. And so I will pause after this one before we go to the Pi. And so now we've made that change. So let's bring back up this device and we'll go ahead and take a look at it. And so what you'll see now is now all of a sudden we're at floating point 32 or floating point 16, and all of a sudden it's slower than the CPU and slower than the FP32, and that's why you have to be careful. And if I were to go in and actually let me go ahead and bring up this bash and let me go into the system, and I will show you what happens a lot of times, and it will. Yes, as you can see, it's very helpful to set your router up with host names so you don't have to remember the IP addresses. So I'll come in. And there we go. And so this is the Jetson device. And they have this nice little tool, and it's in you can look up something called Jetson Stats, and they have a whole set of tools that allow you to go in. And this is the JTOP thing that I've put onto it. So if we look at JTOP, we say, what's going on? Well, the reason it's running so slow is the GPU. If you look at it, the GPU is thrashing at this point in time. It's having trouble doing the translation between 32 and 15. If you look, this is basically at 100% on the GPU. So the GPU is being overwhelmed, and what's happened is the CUDA is not able to handle the 16 precision on this particular model. And that's why you need to, I would start with the 32 bit and then move to the 16 when you're doing it. And sometimes you see a performance gain and not. If you don't see a performance gain, what often is happening is you'll see it thrashing on the CPU if you just go in and take a look at this JTOP system. So that's it. I just wanted to show you where sometimes performance doesn't work on that. So let's go to questions on this before we do a Pi deployment.
Okay, sweet. So I know last week you mentioned that we don't yet support the Google Coral Accelerator. Do we support an Intel accelerated? So we do support the NCS. But
yeah, so we support the Myriad processors. And so right now for building pipelines, we support the NCS2, and we'll show how to use that in just a second on this one. And then we also support, we're going to support different Myriads, but they will set up pipelines differently. So the first one we have is a camera called iCloud. The next one we're going to be working on Myriad-based cameras is the OAK-D system that we have out there. And then if you need to know anything, we have several people like AB who's been on this thing. He's won, his team won actually or not won, but they finished second or something, I think, on it. Well, that's winning on the competition that OpenCV had on the OAK-D. So you can get information on how to use that from him before we formally support that, or other people on Discord. So just put the question up on Discord saying, hey, I can't wait for alwaysAI to get there. Can you show me how to use the OAK-D? And you'll find there's a lot of community around that, but we will be supporting the pipelines and so forth on that coming up soon. Hopefully I can get it into this sprint. So on that.
what edge device do you recommend that alwaysAI users start out with or deploy to for production? Yeah,
so this is going to hurt me to say this. Just take a look at the NVIDIA devices. So if you want to start out development and just kind of get a low end one to do that, Jetson Nano has an entry level one that has about 2 gigs of memory on it. And I would start out with that one. It's like $50 or so forth. But really any productions, you're going to want to use the Xavier. And the Xavier is about $400 and it has everything in there. But the Xavier's got the GPU, and it's really, you can choose either one. There's an XM and AG. I would, XM is a little bit more modern. AG has a little bit more. It's a longer tail system, but but you really want to use those two devices in an ear. And that's where our customers that are truly going to production mode are using the system. Pi's fun. I love my Pi. But it's more of a hacker platform. I know they've done production stuff and there's some things you can do to it to speed it up and everything, but really your Jetson devices are your professional devices.
Yeah, and when you say Xavier, you mean specifically the Xavier NX, right?
Yeah, the Xavier NX, we are going to be supporting the AG. There's commercial customers out there that want the AG thing. So that is on our roadmap to get it out there pretty soon on that. So it's either one, but right now it is the NX that we support on it. So, and we will use an NX soon. If I can get over, I'll go ahead and quickly deploy to a Pi and show that real quick. And then we'll go over to an NX. And one of the reasons I wanted to come back to the NX is we're going to actually use semantic segmentation on it. And how do you do that real time and so forth on it. And I'll demonstrate the NX on that. So we can even, well, you want to, we're here. Let's go ahead and deploy to an NX. How's that? On this one. Yeah, I may not see the water bottle, but I'll move the water bottle. That's the beauty. The water bottle can be moved. So we'll come in and let's go ahead and do an app config. Well, let's first of all take a look at it. So we already know that we're going to thrash. So I don't want to show something in bad light. So first of all, we'll move this back to a 32-bit precision. Remember, it was moving around 54 milliseconds on this system. So let's go ahead and take a look at the Xavier here. So we'll go ahead and we're going to target that device now. And again, I have it saved off. And so we'll say, yep, let's go to remote device. And we'll use a saved device. Oh, lo and behold, there's the Xavier. And we'll come into that device. But anyway, computer vision is going to be big. It is big. For developers, let's get serious this year. Let's go ahead and do that. Wow, that's not good. Cannot connect to device. Well, that means that's not good. So there you go. So my SSH is failing for some reason. So I need to take a look at that and find out what's going on that. So never fear.
Sometimes if I just ping it myself, it will wake up a little bit more or something.
No, I think that you have to actually turn the device on, Lila.
Oh, that works. Yeah.
And so, and what's really great about these devices is the green lights. So for some reason,
That's true.
So when the green light is off, so there we go. So to connect to the device actually has to be on. And so we'll go through and we'll start that process again. That's embarrassing on that.
No, it's always good because I'm sure happened to everyone.
Yeah. So what it tried to do is connect to an unconnected device. And that's what you'll see in these error messages saying host is down. So not only that, our error messages were correct, or the SSH error messages were correct. The host was down. So I think the host is back. Let's go through this process again. Yeah, we'll choose a remote device. And hopefully it has booted by this point in time. It should. And we'll go to the Xavier. Oh, look at that. Yeah, come on. There we go.
There we go.
You have to turn the device on. So I think that's troubleshooting 101, that call help desk. Is your system on? Well, I would have had to tell the help desk that no, my system is not on. So on that. And then again, we'll do the app install process. Going to build the Docker images out. It's going to install the model as we saw on the path thing. And again, so here, I've moved from the Nano, now I'm moving to the Xavier, and then we're just going to run this one, and we'll see how fast it is. So now it's building the virtual environment. That sometimes takes some time when you first do it because it's loading in the Python software. People say, why is it? Because it's actually building the virtual environment for execution when it first hits the device. And so it takes a little long to it's downloading and loading in the Python virtual environment right now and bringing in the libraries for that. So that's why you'll see that hesitate the first time and goes pretty fast after that. Start. And there we go. I'm untrusted, always on an X11 forwarding. I don't know if I should take that as an insult, but anyway. And so it's loading to the GPU. There it's loaded to the GPU. So let's go into the Xavier and let's see how it goes. Let's see how it goes. Come on, Xavier. And there we go. And of course, it doesn't see, it sees a window shade this time, kind of. The camera's right here on me. But we can see that. Let me go ahead and we'll get the water bottle in front. Let's see if it sees the water bottle. There we go. There's the water bottle being done on the classifier. So it sees a water bottle, sees a window shade sometimes. Oops, it stopped. I lost my connection. We go ahead and get that back up. And so, and we went down, but what you can see here, well, I'll hold it up and do it, is remember we were at 54 on the Nano, and this one's running about 20, well, it's in the 20s on the system. And if I were to come out of this thing, we can see on the library systems that coming back up here. So it was doing total frames, 15 frames per second and so forth. The GPU will even go faster as it warms up. So the Xavier is a very robust platform. And a matter of fact, let's, does anyone, I can run on the Pi if they want to see, you want to do the Pi, or do we want to go over, maybe look at some semantic segmentation? So we'll let the community decide. What do we want to do?
Well, we are about 20 minutes over the time.
Okay, well then I won't keep running on people.
But I definitely think these are really good topics to cover for future Hacky hours.
Yeah. But let's take the question. Any questions we have?
So there is a request for semantic segmentation, so maybe let's do that.
So let's do it. I mean, what the heck? I'm sorry that I took up all the time on it. This is why Como doesn't let me do these very often. As unlike the rest of her.
That's not true. That's not true.
She lets me do them. Yeah. So we'll go ahead and we'll do semantic segmentation. So let's just take a quick look at what we're doing on the semantic segmentation side. And anyway, so on semantic segmentation, so let's talk about what is semantic segmentation. So semantic segmentation actually classifies each and every pixel on the system. And we have some sample apps up there from, if you look at the NVIDIA ones, we have, you can see what an autonomous vehicle runs, and run it actually, and run it on an Xavier. And it shows you, autonomous vehicles love semantic segmentation. And let me step back. Where would I use semantic segmentation? Semantic segmentation classifies every pixel. So each pixel is associated with something. So what are these types of applications good for? Well, when you want to classify an entire environment. So what are the use cases on those? Let's start in medical, X-rays. So they're very good for, you have an image, you want to classify that image and every pixel in it. Why? Because I'm looking for a tumor, I'm looking for something in that, break in a bone, something in that X-ray. And semantic segmentation is very good at that. Another thing that semantic segmentation, is good for is taking a look at the quality of say a piece of pipe, an automobile. So it looks for flaws. So you're going to go across that entire image and look for flaws in the like say the piping or something else like that it's used. So if you're trying to do an entire image, it's great, or frame. What's the biggest use to that? It is the autonomous vehicle. We have an example of that with Cityscape, and it will show you driving the Toronto area on it. So if you want to take a look and you have an Xavier type of unit, because otherwise it's going to go really slow, go ahead and run that application on it. This one we're using on the semantic segmentation, and we're using the accelerator on this one, the NVIDIA accelerator, as you can see. what we're going to do is it's designed off what we call the visual object competition, right? And that's a classification of 20 different things on it. So what we've done with this one, it gets really interesting. Instead of coming back, one of the things on the object map, so the object map is the classification. It brings you back a map that you lay over the image that shows you everything that classified by pixel. So it's a pixel map that has what it's been classified as. We also, I should say, it comes back as a mask here. You get the object map, but we also have a capability. I'm looking for it right in my thing. We also have a class list, and what class list allows you to do is focus in on individual objects within that instead of the total object. So what it will do is simply overlay where it finds an object, like a bottle, in this case, a person. What is that good for? Well, what it really is good for is the training purposes is when you're trying to figure out what to do with your semantic segmentation model and you're in the training purposes of it. It allows you to go in, let's say, I want to make sure my autonomous vehicle can find cars. So I'm going to want a class list on cars and make sure it's picking up all the cars. Why is that important? Well, you can figure it out. If autonomous vehicle misses cars or pedestrians, it gets bad. And so this allows you to do some focus. So I'm going to take this, what is called we look up here, a fully convolutional neural network. It's an Onyx model, and it's Cal Berkeley. It's in our thing, and I'm going to go ahead and focus in on 2 of the 20 objects. And so all I have to do is put a class list up here that I'm going to put into our APIs, and I'm going to look at bottle and person, most likely things to find. So with that, that's the semantic segmentation. Follows similar to what we saw with the classifier or the object detector. So we're good to go. So let's go ahead and do an alwaysAI app configure, and I promise I'll move faster. And I'm going to go ahead and, like I said, some of these projects are already here. So I'm going to go ahead and set up my project. Yep. I'm going to create my files. I'm going to run on a remote device. And then what I'm going to do is use the save device, and we're going to go back in and we're going to send this to our Xavier system. Create our Docker file. And so now it's checked whether we have all the permissions and everything. Where do we want to set up the directory? And then we're going to go ahead and install. Build a virtual machine, and then what we'll do is we'll just start this app, and then I promise we'll be done here on this. And you can see here are the 20 different things that it will classify and so forth. So let's go ahead and let's renew our streamer. And see, we can see that what we have right here, this is the model, this is the inferencing time. So you can see it's going through and it's able to classify all the pixels it sees at about 26 milliseconds. And that's really good speed on it. And so we also have an index of what we're doing. So we can see right here, my bottle is purple. What's a person? Or not purple? Well, I don't know what that is. Magenta, is that fair? I don't know on that one. So
it looks purple to me. Okay,
and then we have a person is right here. Person's kind of a lighter purple, right? And so forth. So what I'm going to do first is bring up the bottle. So if you can see the bottle right here, it's classifying. It's not great, but it's classifying. You can see it's also classifying my hand. So those are the pixels it's associating on it. You know, you want to improve this model, but that's not bad for a real-time classifier. It's going through and it's associating those pixels in the pink. And it's like I said, the impressive thing we want to show is the speed. Model definitely needs some work, but there you go. It's going ahead and it's classifying all those pixels associated with the bottle. If I put the bottle up on that. It's tough too, because that is a thing. You know, if I come over here, it thinks my bald head is some reason a bottle. I'll take my glasses off, and there you can see it's classifying me and so forth as a pixel. Every now and then it thinks I'm a bottle. I don't know why.
Well, it has you as purple, which is labeled, well, it's a person, yeah.
Yeah, but the stronger pink magenta one, but that's, you know, classification in real time. I'm gonna put my hand up. Let me move my hand into it, so let's see if it classifies that. Yeah. Here we go. So that's a real-time classifier running, or a real-time semantic segmentation classification, doing it at a pixel level and so forth. Not perfect, got to work. You know, the model needs some work, but definitely the NVIDIA device is able to carry it out and so forth. So that, I'm sorry for running over the things I missed when I wanted to show you how to use your own model, and maybe I'll come back on it. And I did want to go through the Pi accelerator. So I'll do that at a later time if invited back.
You're always invited back, Steve. Okay, so there is a question here. How many cameras can the Raspberry Pi 4 or Jetson Nano handle for inferencing? So how many would you say each one needs? Max can be supported.
So on it, cameras, you know, you're going to have their USB cameras. Maybe you can have two. I'd recommend no more than two on an edge device if you're going to tie it up on that. And then I've also never on a Pi, you could run two models with the accelerator pretty well. The Jetsons, unfortunately, they're really, they use a, you might get in contention on the GPU with the Jetson things. They're optimized really to run one-to-one. So on that, really on it. We probably can do some testing on that. It's a really interesting question on the models. I'm just thinking about how the GPU flows and so forth, and it would seem difficult to me that you wouldn't have contention on the GPU if you tried to run more than one model. That's why people have cloud, and what I hope they get the Jetson to, they have what they call multiple devices of GPU. So there's only a single device, but we even have it in our APIs that there's a parameter we've hidden called device. So if they get the Jetson up to having two GPUs, you can load it, you know, you'd have GPU bank 1 and 2 or device 0 and 1, the way we count, and our GPUs can support that because we're getting ready in case somebody wants to use an x86 and run cameras back to that and support multiple devices where they do have multiple device types. So anyway, long answer, but on the Jetson, if you're going to run on their speed, it should be 1-to-1.
Great. And then there's a question that says, can you create projects without a camera or a webcam to do something else? So I think this is referring to like image classification with existing data.
Yeah. So you just take a set of, so we have APIs, and if you look at the ones, and the reason I went the direction I did to real time is all of our sample applications on classification are simply images coming across, and we have tools to parse those images. We also can handle web videos coming in. So if you see they're not only can we stream webcams, but we can stream videos through, and they can run it real time, or you can go ahead and buffer those coming in too. So you don't have to have a webcam to work on stuff. And a matter of fact, if you looked at the autonomous vehicle one, because we wanted to show driving through Toronto, obviously it's just film coming from that piece.
Yeah, and I've received a lot of questions like this before too. So this guy, I'm sorry, he's clarifying that I have two cameras on the Jetson Nano on the CSI port. So you're saying to just use one camera. Is that your recommendation?
That's my recommendation, because you're going to probably want to bring them. I know they have two and everything, but you're going to want to inference, against those things. So I would recommend just using one, but you can use two. There are stuff in a single inferencing engine on it. I think we have. I'd have to defer to Lila. I think she's done two camera inferencing or so forth. Lila, there is something out there, isn't there, on two cameras?
Yeah. Well, I know I've done it before. I believe it's on Discord somewhere. There's like a code snippet to do it. there's definitely a blog that shows you how to combine two model input and then concatenate the output. So it would be the same process. You just need to say new streamer, new webcam streamer camera 0 is reader 1, new webcam streamer camera 1 is reader 2, reader 1.read, reader 2.read, and then you'll have 2 frames and you can do whatever you want on them, combine them together and send them out to the streamer. So it's definitely possible. It will slow things down.
Right.
So
what I wanted to make my point. So yeah, so you want optimal 1-to-1, right? And my thing is on the inference engine themselves. The inference engine loads the model into the GPU. And if you only have one GPU device, which the Jetsons are limited to, if you tried to load a second model, it's going to be loading the GPU stuff, unloading it, loading it. So that's where the thrash is going to come. And that's why I say I would stay away from dual models that are going to access the GPU unless you have multiple devices. So if you're up on the cloud or you're up on an x86 system, you probably will have multiple GPU banks or devices, and you'll be able to say, load this model device 0 and load it to 1, load it to, and that's where it is. So on the thing, let me be very clear. I would recommend 1-to-1 on that. And I would never try to inference 2 models on a GPU right now, the way the Jetsons are done.
Okay.
And that's why.
Yeah, and I think AB wants to add or maybe ask.
Okay, yeah, let's get somebody in who's smarter. AB.
So actually, I would like to, I've not tried that, but I was trying to answer that question, but it is little political there. So you answered it right. So first thing is like for Pi, if you're doing only with the Pi, it's 1 camera. Don't go with 2 cameras. It will stall your system. If you use Myriad NCS2, you can definitely use 2 cameras. You can even run 2 models as well.
Yeah.
It runs just fine. Coming back to Jetson Nano, you can use more than one models, multiple streams. You can do that, but you will have to use their proprietary Deep Stream SDK to do that. So if you use Deep Stream SDK, you can run accelerate. They have some accelerator plugins. So definitely, first of all, you need to convert the models into TensorRT for sure. And then they have a nice layered architecture which can run multiple models, different kinds of models as well. Like you can run a BERT model which is doing NLP. There's one model which is doing pose detection and one which is doing object detection. They have that kind of showcases and demos. This kind of demos really work well on Jetson NX or AJX, which on Jetson Nano, I would stick with maximum 2 models max, not more than that, because that will stall the system. But that is definitely possible using Deep Stream SDK.
Okay, yeah, I'll have to take a look at that, AB. Thanks for that, because again, you still have a single device, and just the way I know even how TensorRT works, it really loves to, it needs some warm up time and things like that. So I'd really be, you're going to be popping that device.
I haven't tried that. That was my disclaimer. But I've seen demo, and I know one guy who has tried the full CCTV. He has a full CCTV fleet running on Jetson Nano, and then he changes to Jetson NX, and he's doing the detection of like if anybody's coming there and if people detection and all that, running on RTSP streams, all feeding into Jetson Nano.
Okay. Yeah. I think you can queue things up and so forth and have it, multiple screens and do that type of thing. What I was worried about is 2 models loaded at the same time and how they might have to thrash and unloading them to devices. But I'm going to go ahead and take a look at, you've now put a challenge down on the NX, and I'm going to have to go take a look at that and see whether I can break that system. That will be fun for me.
That would be really cool. Yeah.
Yeah. So I'll take a look at that. Again, let me know.
I am happy to collaborate as well. So
yeah. So this is a good challenge. So I'm going to go ahead and take a look into that one. But right now, I would say with our software, that I would just recommend running one at this
model
until AB says we solve our software problem that we may have that NVIDIA has already figured out. So I'm going to go ahead and see what NVIDIA did, and then I'm going to go ahead and see if I can do something that can pop between the models and so forth. And multiple cameras. But right now, 1-to-1. I would
Great.
recommend.
Good. Okay. Good to know. And thank you, AB. And what kind of resolution do you think you might get if you had like 2 cameras connected?
So again, remember the models are going to downsample. Okay, and that you have to be aware of. So like a YOLO model, you can set it up for different resolutions and so forth, but just take a look in our model catalog. We'll say how big images should be and things like that. And that's the downsampling of models. And so I think like MobileNet SSDs running at 300 by 300. So you can have your camera be whatever you want, but it's going to downsample the system. So I just want to make that type of warning out there on it. So
Great.
Oftentimes I've seen people actually use less, if they know it's going to be at 6. So, 600 by 8, right? I think Steve, one of our guys, is working on it. He's actually finding smaller cameras that match the sampling size on it for speed and reasons and so forth. I think that's what's happening, Lila, right?
Yeah, I think that's what I was thinking when you mentioned that Steve had said it might be better to have a poor resolution, not bad, but not super high because then you're just spending time.
Yeah, but you will downsample to your model. So watch how, and again, with model retraining, you could actually, and it may get you more detail, right? You could train at a higher resolution than what the default on the model is and so forth. So you can manipulate those layers, I believe, in the model retraining. So if you use our model retraining, you can go up and you will have higher definition type of stuff. It will be a slower processing piece, but you can do that.
Sweet. Yep, that's all the questions we have.
All right. Hey, so apologies for going too long. I love doing these things and spending some time on it, and got some great questions from the community and some ideas on hacky hours in the future.
And some good feedback too. So AB said, Steve is a teacher whose class is never boring. I swear.
Well, thank you, AB. Appreciate that. All right. Well, thank you for your time, everybody. And we'll see you next week.
Yep.
And next week will be cool. I guarantee it. I have fun with next week's stuff. So
yeah. So on that's a plug for next week. We're going to be building an interactive web app with alwaysAI. So join us, and that's going to be led by Lila. So
and Eric, we're going to get Eric.
Yeah, Eric's. Yeah, and if we have to split it up, like do Flask and then Dash the subsequent week or something, we might do that.
Okay.
See how long it takes, but I will be there. And Eric will probably be the star of the show, at least to start.
And I get to learn.
Yeah.
This is.
I feel like we always learn. I learn whenever I do these things. I feel like I learned things today.
Yeah, and that's the intention of Hacky Hours, right? For everyone in the community to collaborate, learn from each other, ask questions. So thank you so much for joining, everyone, and we'll see you next week.
All right, thanks.